Hello, algebra students. Today we are going to talk about one of the most important basic concepts of algebra, and that is called substitution. We're going to do it today while we evaluate some algebraic expressions. And I'm super excited to tell you that today we have Mason with us. One of my, well, I don't have favorites, you guys. You know I'm better than that. But if I had favorites, Mason would be at the top of a very long list. All right, let's get started. We'd better define our terms. We'd better know what an expression is and what it means to evaluate one. An expression is like a mathematical phrase. That's how I think of it. It's not a complete sentence, but it's like a part of a sentence. I'll give you an example. Let's relate it to English. I could say the fat cat in English. That's a phrase, but we don't have much information about the fat cat. We don't know where he sat. We don't know what he ate. We don't know where he's going. We just know that somewhere out there, there's a fat cat. And so it's the same thing mathematically. When you have an expression, a math phrase, we have some numbers. Like, for example, I don't know, 2, 7, and we could have some operations like plus, minus, multiply, divide. We could even have some variables like x. And so we have this phrase here, 2 plus 7x, but we don't know anything else about it. Just like when I say the fat cat, I don't know what the fat cat's doing. Same thing here with this. I have 2 plus 7x, but I don't know if it's equal to 14, if it's less than 11. I don't have a lot of information about it, but there it is, just sitting there, that kind of mathematical item. And so you'll probably see it defined as some combo of numbers. Now, it could just be really simple. So like 5 is an expression, but it could have more. It could have operations. So like 5 squared or 5 plus 3, those are all expressions. But it can also get more complex in algebra and have those letters, those variables. So like 5x plus 3 is also an expression. All 4 of those are examples of some simple to some more complex expressions. Okay, so next word we need to define. If we know what an expression is, and today we say we're going to evaluate expressions, well, we better know what it means to evaluate. We have another word for evaluate. We call it simplifying. And I know that sounds familiar because I beat you around the head with that word. And we're trying to basically do the math as much as we can. What I mean is when you see add, you'll add. When you see subtract, you'll subtract. Like obey the symbols. So let's go back to one of our original expressions, 5 squared. If I asked you to evaluate 5 squared, you would just do the operation. Do you remember how to square a number, Mason?
Isn't that 25?
It is. Yeah, it's the same as 5 multiplying by itself, or 25. Nice. You've just evaluated. So seems easy, right? Like, why are we doing this? This is back to the basics. Didn't we evaluate before? Well, once we hit the land of algebra, sometimes evaluation gets a little tricky. And I'll show you what I mean. Mason, I have this expression. This is an expression, right? 2x plus 1. It has some combination of numbers, operations, and variables. And I don't know anything about this expression. I don't know what it's equal to. I don't know what it's greater than. If I were to ask you to evaluate it, you'd be in trouble. Would you be able to do this addition? Would you be able to do this multiplication?
No.
No, so why not?
Because there's nothing to simplify?
There's nothing to simplify. You're right. But the question is why? I mean, usually when there's a plus sign, like for example, if there was 2 plus 1, I could do that math. Or usually when there's multiplication, like if it was 2 times 7, I could do that math. I could evaluate either of those expressions. What's wrong with this guy that makes the addition and the multiplication impossible right now?
My best educated guess is because with 2x, we don't actually know what x is.
You bingo, Mason. We don't know what x is. How can we multiply an unknown number by 2? How can we add 1 to whatever we get when we multiply by 2? Like, we can't do this until we know that super important piece of information. Mason says, what do we need to know? So we need to know the value of the variable. So right now, there is literally nothing I can do to 2x plus 1. Don't be the student who looks at 2x plus 1 and tries to do all kinds of crazy stuff for me. Mush it together, try to figure out what x is equal to. You have no clues until I reveal the mystery identity of x. And that's what we're going to look at today, when you know what the variable is. So then you're able to evaluate an expression. Awesome. Let's look at an example. Okay, this should look familiar. I still have this language, evaluate the expression, and there's that expression we were talking about, 2x plus 1. But look at the information I have this time. I gave you more information. I don't just tell you to evaluate 2x plus 1. I have solved the mystery for you. What piece of valuable information do we have now that we did not have before?
X is equal to 7.
Bingo! X is not a mystery. X is not unknown. X is 7. And so that is the key to unlocking this sucker. That is the key to evaluating it. X is a known value. And so we are going to do one of the most crucial skills to algebra that is called substitution. And substitution is basically trading one value or expression for another equivalent value or expression. So we had said x is equal to 7. They're equivalent. That means anytime I see an x, I could trade it out for a 7. Now, super important thing for everybody concerned, I need to teach you how to write a math essay. So I have good news and I have bad news. Let's start with the bad news, since y'all like to whine at me for this all the time. Yes, this is going to require you do 3 things, you poor, abused math students. And I'm going to ask you to do those 3 things every single problem today. So that is the bad news. Kate's a jerk. She wants you to do a lot of work. But here's the good news. We can still do those 3 things in a very few symbols. If I was asking you to write an English essay, you'd be writing 2 pages. I would just appreciate it if you guys would not whine at me for 3 lines. Mathematicians are lazy. You could be lazy with me, but this is the least amount of lazy I'm going to let you get away with. And there's a reason for that. It's because I need you to learn to communicate in the language of algebra. So on the GED, will they check that you have these 3 lines? No, they will not. You will just need to know the answer. However, if you would like to become proficient at algebra, which is what you need for the GED, you need to speak the language. So we're going to practice today speaking the language. So here are the 3 things I want. And once again, it's going to remind you of English class. First, I want your original expression. In math class, we always start with something that we can all agree on. We all agree on the original expression. So even though it's written up above, we're going to write it down ourselves. Which part of this was the expression?
2x plus 1.
Absolutely. So that's the first thing I'm going to do. I'm just going to copy down 2x plus 1. No changes, no nothing. This communicates to every mathematical person that I am writing to, talking to, that this is the known thing that we're all starting with, that we all agree on. And it reminds me very much of the introduction when you're writing an essay. Now, the next thing we're going to do is our substitution. If you were with me doing Crucial Basics, you learned to do this in your calculator, which is awesome. We'll check our work today in our calculator, but we're going to practice today doing substitution by hand, because this is a core skill of algebra, and it is going to be used over and over and over and over again in any college class you proceed on to, any college math class. It's super important to also know how to do this by hand. Mason, have you ever been in school and had a substitute teacher?
Yes.
When you had a substitute teacher, they came into the classroom. Was the other teacher there?
No.
No, right? Why is the substitute come? Because your other teacher is not there. They're gone. So same thing when we substitute in math. If we are going to say, oh, X is not a mystery anymore. I know what X is. X is 7. Now I'm going to rewrite this expression, kind of like having the class there. But that X, it's gone. 7 is going to be there in its place. Of course, I need the rest of the expression. There was a 2, there was a plus, and there was a 1. I'm not finished yet. There's something that I haven't considered here. This kind of looks like 27 plus 1 to me. That's what this expression looks like. But you had told me before that 2 and x were doing what?
Multiplying.
Multiplying. Bingo. So Mason, if I want to signal that this 2 and this 7 are multiplying, how can I do that now that I've reached algebra?
By putting parentheses.
Beautiful. Okay, so I'll put parentheses around the 7. That part, I think of that like the body of your paper. The substitution, that's the main part. That's where you're really making your point and you're doing your math as you think of it. Now, remember I said to you that you could be doing a lot of work here. You could have a longer paper, but the least I'll let you get away with are 3 things: the original expression, the substitution, and the final thing is the simplified expression. What you guys think of as the answer. Another great way to think of it is like the conclusion to your paper in English class. It's kind of where you get to like, oh, this was the point. Now, we have different ways we can simplify, right? We learn to simplify expressions by hand using the order of operations. You're certainly welcome to do that here and check your answer against mine. But because the skill that we're focusing in on today is the substitution, I'm actually going to do the simplifying, the evaluation in my GED calculator. I can just type that entire expression in the way that I see it. 2 times 7, close parentheses, plus 1, enter. And I see that the simplified expression, what you guys might call the answer, is 15. Beautiful. That is the least work you can get away with. Like the intro, body, and conclusion of your paper, you are going to give me the original expression, the beautiful substitution, and the simplified expression. All right, let's get a little trickier. So example 2 says, evaluate the expression 3a minus 2b for a equals 5 and b equals 7. And I said that I would have you do 3 things every time today just to practice our math grammar. The first thing I want you to do is write down the original expression. Then we'll do our substitution, and we're going to practice doing that by hand today. That's the big deal today. And then finally, we want our simplified, what you think of as the answer. Looking at this example, what is the original expression?
3a minus 2b.
That's right. Now, if this was all the information I had, I'd be stuck. I'd be in a jam. I couldn't simplify it. I couldn't evaluate it. I would not have enough information. But they gave me some information. A and B, they're not mysteries anymore. They're known values. And so that'll be our next step. We'll substitute in any known values. Note, I want these 2 things to look identical. This line and the next line, the only change then is that we're going to trade out those values. So if I have a 3 up top, I'm going to have a 3 underneath. But now I have an A up top and I don't need to call A anymore. I don't have to call him mystery number A. I can call him by his name. I know the value for A. Mason, what does my example say the value for A is?
5.
It's 5. Now, if I were to just put it like this, it would look like 35. And this up above didn't say 35. It said 3 times A. They're shoved together. So Mason, what should I do so that I can see that these 2 things are multiplying?
You'll want to put parentheses.
Brilliant. I'll enclose 5 in parentheses. So you can see there's my 3. My A has been substituted with a 5 that's multiplying instead of an A that's multiplying. But once again, it's going to be super duper important not to lose anything from up above. So if my original expression has a minus, my new expression better have a minus. If my original expression has a 2, my new expression has got to have a 2. But here's where things get different, right? B is not a mystery any longer. I know that B is what?
7.
Yeah, they told me B is 7. So I can replace B with 7. But what are 2 and B doing?
Multiplying.
Multiplying. So I'm going to use parentheses to signal that they're multiplying. And now this line is equivalent to the one above it. The only difference is I traded out the letters for their known values. So I'm going to put the entire expression in my calculator, 3 times 5, close parentheses, minus 2 times 7, close parentheses. So that entire expression simplifies to just 1. Original expression, substitution, simplified answer. Yeah, math students just throw around the word answer like it has some mathematical meaning. And the answer, what is the answer, depends on what I've asked you to do. But here I've asked you to evaluate or simplify an expression.
I noticed when you did the simplified answer, do you have to have the equal sign down at the bottom?
Brilliant. So again, we're talking whether you're learning to speak the language or you're just finding the answer. On the GED, it'll just be multiple choice. You'll just have to pick the number. But what I'm trying to teach you is the language right now, because the problems on the GED get pretty complex. Because you're going on to college, I want you to be fluent in the language. So as we go down in algebra, each thing below is supposed to be equivalent to the thing above it. So what I'm saying is I have this true thing, and now this is going to be equal to that true thing, and this is going to be equal to that true thing. And as you go down, I'm supposed to be able to follow your logic that, oh, of course, if that's true, that must be true. If that's true, that must be true. And so that's why we use that equal sign. We're like proving it to somebody. Like, if you believe me here, then you have to believe this next thing. It logically follows. So show it to me in your work. You won't have to put it on the GED. That's the short answer. All right. Excellent. Good question. I bet everybody wants to know that. They're always like, what's the least I can get away with, Kate? So beginners, that's quite enough for you. You have enough to be getting on with. Go practice this skill, because even at a really beginning level, it's super duper useful. But experienced level students, let's look at some tricky ways that this can show up and see that it's just basically the same skill. It says the cost per bicycle of producing X bicycles is given by the expression, the quantity of 35X plus 10,000. And I want to say the quantity because that fraction bar is under that whole thing, divided by 20X. What is the cost per bicycle when producing 200 bicycles? This might look a little different. This might even be scary, because I know a lot of students are like, well, word problems are hard and algebra is hard. So if I put them together, it must be like impossible level. But actually, this is one of those cases where algebra is going to make your life easier if you don't like word problems. And that's because, look, they gave you the expression here. Mason, do you see the original expression that they gave us?
35x plus 10,000 divided by 20x.
Beautiful. The sum of 35x and 10,000, or the quantity of 35x plus 10,000 divided by or over 20x. Nice. And even though they didn't say it in the language of algebra, they gave us a value for the variable x, bicycles. They're telling us what x stands for. The numbers of bicycles that they produce. Awesome. And then the word problem goes on to tell us that number. It tells us how many bicycles we're producing. Mason, according to this problem here, how many bicycles am I producing?
200.
I'm producing 200. So they might have told me in English instead of in math, but basically they said, X is the number of bicycles you're producing. You're producing 200 bicycles, so X is 200. So now that we have a known value, let's do our substitution step. Let's trade out the variable X for its known value. Now, make sure you have that nice long fraction bar. Don't lose that. And then, of course, don't lose any numbers, right? Like we have 35X, but do trade out. X is for the known value. You told me X was what, Mason?
200.
200. So I'm going to plug that 200 in using parentheses, because 35 and X are shoved together. They are multiplying. I won't lose any symbols like addition or any other numbers. I want the two expressions to be absolutely equivalent to each other. The only difference is I'm substituting out the values. So I still have my 20, but my 20 on the bottom is now multiplying by 200. For those of you guys who struggle with algebra, take a look at how I'm using a different color to show the changes made to the expression. That can help you if you get lost in the symbols. Type the entire expression into your calculator by first hitting the fraction bar. Should be a nice horizontal line, just like I have. If yours is at an angle, it's diagonal. Go change your mode to math print mode. And then I'll type up top 35 times 200, close parentheses, plus 10,000, arrow down, and do 20 times 200. And now I get this interesting answer, 17/4. Now, first of all, there's nothing wrong with this answer. It's true, it's correct. Don't freak out if it doesn't look like the answers in your multiple choice and think, oh my gosh, I did something wrong. Numbers have more than one form. We know that fractions can also be expressed as decimals. And in this particular word problem, it makes a lot more sense to express your answer as a decimal because of what it is. Let's go back and look again at what we were looking for with this expression. It said the cost per bicycle is given by the expression. If I asked you, Mason, how much did this cost? You probably wouldn't give me an answer as a fraction. When you go to the store, nobody says it's going to be 17/4 of a dollar. And so I'm going to use the quick convert button to see, oh, that's the same as 4.25 or $4.25. Now that's how we would be more likely to express cost. Cool.
If you were trying to change 17/4 into a decimal by hand, is there a way to show how you would go about that?
Yeah, so I'm not going to do the computations with you because that's not something tested on the GED, but I will tell you how to do it. It's all based on that operation. If I have 17/4, that's one way to think of it, but we know that fraction bar also means an operation. What operation does it mean, Mason?
Divide.
Divide. So if I took 17 and divided by 4, you know what I'd get? 4.25. Or Mason, I could have just done this too, by the way, 17 divided by, instead of regular fraction bar, 4. So another way that this skill of evaluating can show up is actually with just about all of the geometry on the GED. And again, you wouldn't necessarily recognize it, but take a look at this. It says a triangle has a base of 4.2 centimeters and a height of 7.3 centimeters. Find the area of the triangle. Now you might say, well, Kate, I don't know anything about triangles and I don't know anything about area. And that's actually okay. When you go to take your GED, you will have the GED formula sheet. And I want to show you something cool on there. You will have this during your entire math test. And you can see right at the top there, that first section says area. And go 4 lines down and you're going to see we've got the area of a triangle. There's some math speak right there. There's a formula. It says A is equal to 1/2 BH, or B times H. Let's go ahead, write that down, and then I'm going to show you how this is, even though it looks a little different, the same stinking skill. Now, I had told you that the first thing I wanted you to write down was the original expression. And you might say to me, Kate, this is not an expression. I attended last class. This is an equation. A equals 1/2 BH. Look at the equal sign. Look, there's something on either side. Not an expression. This is an equation. And I would agree with you. This whole thing altogether is not an expression. It's actually 2 expressions. Remember that that's all an equation is. It's an expression, in this case, just plain A, equal or equivalent to another expression. Yeah, it looks a little different, but I still have a couple of expressions here. And so that means that if there's an expression on the left-hand side and an expression on the right-hand side, I can still use that skill of evaluating expressions. That being said, let's go ahead and do it. So we have an original formula, and we're going to plug in any known values. So go looking through this problem. Do you see any values, any numbers?
Yeah, I see that we have the base of 4.2 centimeters.
Good. A base of 4.2 centimeters. Yeah, guys, I mean, I shouldn't say mathematicians aren't creative, because We are creative, but we're not that creative in naming things. Base, that's what this B stands for here. So if I tell you, if I have a base of 4.2 centimeters, I'm just telling you B is equal to 4.2. Okay, any other known values here, Mason?
Height of 7.3
Right, a
centimeters.
height of 7.3. Take a look at this formula. Which letter do you think I'm using for height?
H.
H, yes, H is 7.3. Now I have some known values. I'm going to go ahead and plug them in. I don't know what A is, and that makes sense because they told me to find the area. So A will stay A. My equals will stay equals, and I won't change any numbers. But I do know what B and H are, so let's substitute them in. Now, don't let the fraction freak you out. The 1/2, the B, and the H, they're all shoved together, so they're all multiplying. So my B will be in parentheses, and my H will be in parentheses. Awesome. What did you say B was, Mason?
4.2.
4.2. And what did you say H was, the height?
7.3.
7.3. Beautiful. And now, no, this isn't an expression altogether, but if you just look at one side of the equal sign, it is an expression. And look at the expression on this right-hand side. Do you see any letters in it anymore, Mason?
Nope.
No, it's just a bunch of numbers. It's just an expression that our calculator can simplify. So to type this into our calculator, first we'll type the fraction bar, n over d. We'll type 1 on the top, arrow down to type 2 on the bottom. Now, super important here, I need you to arrow out of the fraction before you open up the parentheses, or you'll be putting that 4.2 inside the fraction, which is not what we want. So 4.2, close the parentheses, open up again, and I get 7.3. Close parentheses, press enter, and this entire right-hand side simplifies to 15.33. And what was that equal to? That was equal to A. And now I'm just saying, in the language of math, the area is 15.33. Now, I know enough about geometry to tell you that that's 15.33 square centimeters. But for now, the main thing here is the number.
I noticed that you made a square with centimeters squared. Is that important?
It's important to understanding geometry, but it wouldn't be part of the answer that you'd have to figure out yourself for the GED. And since this isn't the geometry unit, I'm not going to focus on that part of the skill yet. But it is important when you get to geometry to understand that area is measured in square units. Like if I ask you, how big is your house? You don't say my house is 1,000 feet. You say my house is 1,000 square feet. Okay, another one for my experience level students. Why am I saying this one's tricky? Well, it's the negatives. Let's take a look. Evaluate the following expression for x is equal to -1 and y is equal to -3. And then they have our expression 3xy squared minus 2x squared y. This is a GED favorite. They love examples like this, ones where you have negative values that are getting plugged into exponential expressions. When you put a negative in with an exponent, it's really easy to screw something up. So this is the important thing you need to take away, especially if you're going on to college. You must, every single time, tattoo it on you guys' foreheads, okay? You must use parentheses when plugging negatives into exponential expressions, basically where there's exponents. Even the most simple example of exponents. If I tell you to evaluate a squared for a equals -2 and you don't get a parentheses, you'll get the wrong answer. A lot of students would just say, hey, I'll replace a with -2 and I'll square that. And if you did that, you'd be wrong because your calculator will tell you -4. You need to plug in the number in parentheses with the exponent on the outside, and then you'll get a different answer, +4. So this is not correct. And it has to do with the order of operations. It's the grouping. When I use those parentheses, I'm telling you to square the whole number. I want you to square all of -2, not just the 2. All right, that is what we walk away with. Now let's go ahead and use that. So nice thing about this guy is the original expression's already written down for us. It's right there, right on top. Here it is, 3x y squared minus 2x squared y. But if you were going to take your GED, this would not already be on your dry erase board. It would be up on the screen. And it is a really good habit to just write it down exactly the way you see it first. You'll have less substitution errors. And now I'm going to do my substitution. Like I said, remembering that anytime I plug a negative in, even if it's not multiplying, if it's in an exponential expression, I need parentheses. So here we go. This is going to be equal to 3, but X is not a mystery anymore. I can call X by his name. What is X, Mason?
-1.
Good. I'm going to put that in parentheses because it's shoved against the 3. Now I'm going to open up another parentheses for the Y. What is Y?
-3.
-3. And now I had a square on the Y here. I better have a square here. I have a minus here. I better have a minus. I have a 2 here. I better have a 2. Okay, but X is no longer a mystery. I know X. Again, X is being squared. So I'm going to use parentheses around it, and I'm going to put the square on the outside of those parentheses. But what is X?
-1.
-1. And then that is multiplying by Y, which is -3. All right, now that I have my substitution done, it might be long, it might be ugly, but it's only numbers right now. There's no letters left, and so I can simplify here by typing the entire expression. 3, open parentheses. Now I want -1, so I use the negative down at the bottom. Close parentheses, open parentheses, -3, close them before I square it using the X squared button. And now see how that minus sign this time is between those things on the outside of the parentheses. Now I'm going to use a minus, not a negative. 2 times -1, close the parentheses before I square it if I want the right answer. Open up parentheses and -3 squared. And I get -21. Now, I want to tell you that even though I want you to practice substituting by hand, practice this skill so that you're prepared for college, this is the most commonly messed up substitution on the GED. When you guys have the negatives with the exponents, there's so many chances to lose a negative, to lose a parentheses, to put the exponent on the inside instead of the outside, like so many chances to mess up that a lot of students will get it wrong, even if they've been practicing. And I want you to pass your test. So yes, I want you to skill build, but I also want you to pass your test. So I'm just going to remind you that yes, it's a good skill to know how to do your substitution by hand, what we did here, but you can also do your substitution in the calculator like we learned back in the Crucial Basics unit. So I'm just going to do it that way as well, and we can compare to make sure we get the same answer. And as you do your work today, you can check your answers using this same method. So here I go. If you remember to do the substitution in your calculator, you have to first store the values of the variables. So I know what X is equal to. Let me communicate that to my calculator. So -1, and I'm going to store that, pressing the variable button for X, and I press enter. I've just told my calculator that every time you see an X, it means -1. I'll do the same thing for Y. So -3, let's store that, and then press the variable button twice to get Y. Enter. I've just communicated to my calculator. Every time you see a Y, it means -3. If you store those values for the variables in your calculator, you can actually type the expression in with the letters. And so let's try that. So 3, type the variable button for X, arrow out so that you can get another letter, and I get Y, and I square it. Minus 2, X with the variable button, square that X, and then hit it twice for Y, press enter. And you can see whether I do the substitution myself by hand on my paper, or I do the substitution in my calculator by storing values of the variable, I get the same answer. This expression simplifies to -21. Okay, experienced students, you can get on out of here, go do your practice. Advanced level students, let's keep going. So this particular example, whether you realize it or not, is going to come up in the slope and lines unit because this skill is used all the time when it comes to lines, but turns out it's just an application of what we've been doing. It says if y is equal to -2/3 x plus 4, what is the value of y when x is equal to 15? I don't have an expression this time. I have an equation that relates y and x. But again, like we said before, an equation is just an expression equal to another expression. We're going to start with that thing that we can all agree is true because it was right there in the problem. Now, look what they're asking me to find. They're asking me to find what is the value of y. So they're saying find y when x equals 15. Boom, I got a known value. You got a known value? Plug it in. Let's do our substitution. Okay, Mason, step on up for me. Help me rewrite this equation with my known value in it.
So you first want to put in y equals
Beautiful. Y is the thing I don't know. It'll stay y.
-2/3.
Good. Numbers don't change.
15 with parentheses.
Beautiful. Times 15. They're shoved up against each other. They're multiplying. Let's use parentheses.
Plus 4.
Gorgeous. No change to operations, no change to numbers. Now, yeah, there's a y and an equals there, which your calculator can't do, but we can see on the right-hand side, that entire expression on the right, there's no letters left in it. It's all numbers. I can type this in to my calculator to simplify it. Let's do it. So I'll start with the negative. Fraction bar, 2 on the top, 3 on the bottom. Again, make sure you arrow out of the fraction before typing times 15, and then we will add 4. And we see -6. Now I know the value of y. Y is -6 when x is 15. And we will use that skill over and over again when we talk about slope and lines. We'll find y when we know x. All right, don't let me intimidate you, you guys. You know how I am. It's not as hard as it looks. I'm just a brat, but then so is the GED. So here we go. It says the formula V is equal to 1/3 pi r squared h can be used to find the volume of a cone with a radius of r and a height of h. Use pi equals 3.14 and find the volume of a cone with a radius of 9 millimeters and a height of 21 millimeters. At this point, you might want to puke. It's a word problem. There's some algebra in here. There's some things you never heard of, like radius and height and volume and cones and pi, and oh my. What a mess. But I'm excited because there's some mathematical directions here. I see an equation up there that I can use to figure this sucker out. Mason, do you see that equation up there?
Yep. V equals 1/3 pi r squared h.
Good. And now look at this problem. They're telling me to find the volume. So they're asking me to find V. In order to find V, I would need to know what all those other little symbols on the other side are equal to, what pi is, what r is, what h is. Well, all that information is in this problem. So V is what we're looking for, and that's going to be equivalent to, help me substitute into the right-hand side, Mason.
You first put in 1/3. Pi turns into 3.14 with parentheses.
Yes. So you guys should know that pi is not a variable. It's a set number, a number that never changes. It always means the same thing. But unfortunately, it's a long, ugly decimal that goes on and on forever. So we like to call it pi. But on the GED formula sheet, it does say that you can substitute 3.14 every time you see pi. So that's just kind of a rounded version of pi. So we'll do that. Anytime you see pi, you can plug in 3.14. What shall I do next?
You would put open and close parentheses 9 squared.
Beautiful. 9 is our radius, and then we put the square on the outside of the parentheses. Nice.
Then you'll make another pair of parentheses with the number 21.
Beautiful. And now I'll substitute in my known value for h. My height is 21. And now, as ugly as that might appear, The right-hand side is all numbers, so I can type the entire expression into my calculator. So n over d for the fraction, I'll type 1 on the top, arrow down to type 3 on the bottom. Arrow out of the fraction before I type 3.14, close parentheses, open parentheses 9, close it to square, and then open parentheses 21. And I get 1,780.38. Lovely. Sometimes on the GED, there'll be rounding directions, or you'll have multiple choices that are rounded. But here, I don't give you any hint at rounding, not what I want to practice today. So we're just going to leave this answer right here, exactly the way it looks. And again, for those of you guys who are curious, volume would be measured in cubic millimeters, but again, you can just let that wash over you. Not super important right now. Here's another one. Student C makes them want to vomit, cry, curl up in the corner, get in the fetal position, call their mommies, whatever. But guys, same exact skill. If you understand something about the math grammar here, let's take a look. It says evaluate the function for x is equal to 1.7. There's a nice hint. They told me what x is. And then there's this thing they're calling a function. You read that as f of x. I know that looks like f times x, but we read that as f of x. And it just literally means a function, an equation with x in it. So f of x is equal to negative 0.9 times the quantity times all of this group of 4.2x plus 11.9. Now, we'll look more at function notation, this f of x thing, if you hang with us for the slope and lines unit. But even if you never get that far, you can know this. F of x is just a formal way to say y. It's like this. You have a first name and a last name. If we're on first name basis, I could just call you by your first name. I can be like, what's up, Mason? But I could also be real formal and call you by your last name. I could call you Mr. Smith or Mr. Thomas and talk about your last name as well more formally. I'm talking about the same person. It's the same thing with f of x. It's just a formal way to say y. So if it's freaking you out that bad, write y and you'll feel better. And now we can see this is just something to plug in. This is not some new crazy kind of math. Y is equal to negative 0.9. And I'm just going to write my original expression out with the y in it. And then I will do like I've been doing before and substitute in any known values. Help me out, Mason.
So y equals negative 0.9. Open parenthesis 4.2 open parenthesis.
Good. A lot of students would be confused. Can I open another parentheses? Yes, you can.
1.7.
Good. X is not a mystery. X is 1.7. Beautiful. Now, really important though, make sure you close that parentheses or you're going to get all in a muddle.
You drop the symbol down of addition. 11.9. Close parenthesis.
And then close the second parentheses. Gorgeous. It might be ugly on the right-hand side, but it's ugly with all numbers my calculator can handle. Here we go. Negative 0.9. I'm struggling. Open parentheses. 4.2. Open parentheses again to times it by 1.7. Close the parentheses on that multiplication. Plus 11.9. Close the parentheses on that grouping. And I get that y is equal to negative 17.136. Sweet. Last one, same basic skill, but now I'm just trying to scare you with everything I got. Okay, you guys, you ready? Function notation, word problem, equation, letters, algebra. Stop panicking. Same basic skill. The function below gives the height of a ball, h of t. So again, it might look like h times t, but it's not. It's saying this whole thing, h of t, is height of the ball. So if it freaks you out that much, instead of calling it h of t, just call it h. The height is equal to. A little less scary. Thrown up from a height of 500 meters, t seconds after release. Use the function to find the height of the ball after 2.3 seconds. So there's our function, h of t, or just h, is equal to negative 16t squared plus 80t plus 500. We have our original function, but some of the things that look like mysteries are not mysteries. I have some known values. Go back through that word problem, Mason. What information do they give us to give us a clue about what the letters mean? So we already talked about what h of t means. It means height. But how about the other letter? How about the T? What does this word problem say that T is about?
Seconds after release.
Beautiful. They say that T is the seconds after release. Do I know how many seconds it's been?
2.3 seconds.
Beautiful. It's been 2.3 seconds. So T is not a mystery. T is a known value. That means we can plug 2.3 in every time we see T. So height is the thing I'm looking for. That's going to be equivalent to, I don't change numbers, so that's still a negative 16, but T is not a mystery. T is 2.3. Now make sure you close the parentheses before you put the exponent on the outside. T was being squared, and that's plus 80. And again, I see a T again. So every time you see T, you just plug it in. And I see plus 500 in the original function. I'll see plus 500 in my new substituted version. Now the right-hand side might be ugly. It might be disgusting. It might make you want to vomit, but it's just numbers. And so your calculator can handle computations for you. Here we go. Let's type the entire right-hand side into our calculator. Negative 16 times 2.3, close parentheses before you square, plus 80 times 2.3 plus 500. H is equal to 599.36. Now that might not make a lot of sense to you, but take a look back at the word problem. It says use the function to find the height of the ball after 2.3 seconds. We just learned the height of the ball is equal to 599. And yes, it would be meters. But again, like Mason asked us about before, this is the part we really have to understand in order to select the right answer on the GED test. Awesome. Guess what? You just rocked it through the advanced level of the skill. Like literally, if there is one skill I could give you for the GED for the most point boost, it's this one. Like some of you just got tipped over the passing point just with this one skill. All right, so that's super nice because it just comes up in so many different contexts. This idea of substituting, trading out something for something else that's equal. Oh my goodness, all over the place. That's math. But now that you've got it, you should definitely go practice it. Y'all, my advanced level students, y'all are the worst. I love you to death, but you watch me do something and you're like, man, that was so easy. I'm going to remember this for the test. Then you don't practice. Then your brain just dumps the info and then you go to test and you forget. So please go practice and practice at your level and see all the different applications of this on the GED. All right. I'm so excited. You did so good. Happy learning.